Okay. Hi, everyone. Good afternoon. My name is Yuan. I'm an engineering manager from IBM. So thanks a lot for the Velox community. It's glad to be here and to meet some old friends. It's really a great event, and I really enjoyed it. So for the agenda today, first, I will introduce the key features and we implemented in the past year for Gluten. And then I will introduce some details for some of the key features we introduced last year. And then I will do a short introduction on the IBM Velox Data Spark. And then I will introduce the performance optimizations we have done in the past several months. In general, we get almost 2x performance since last year. And then there's a summary. All right, this is a picture for the Gluten team in IBM. So most of us are based in Ireland, and some of us are in the States, and there are also some new guys from India. And by the way, some of the team members are in this event. So if you have any questions, to reach out to them. And yeah, I'm really proud to be one of the team members here. So in general, we have 7 committers and PMC of Gluten, and we also have 3 Velox committer and maintainers already. And IBM is 100% supporting on open source projects. Yeah, so this is a journey for the Gluten project. So it's been like 5 years, 6 years. So it starts from a very, very small POC in 2019. And then we made some homemade engines based on Arrow and Gandiva. And then we realized the performance and the functionality is not so good. And then we found the Velox project. And glad we found Velox project since then. And we start to implement the necessary functions and the gaps with the Velox backend. We introduced the many functions, many operators, and gradually we came to this way. And in March 2026, so Gluten is finally graduated from the Apache incubation project. So it's a top level project right now. Yeah, it's all credits goes to the Gluten Velox community. So I want to say a big thanks for the community. Here's a picture for the roughly 200 contributors in the Gluten project, expanding from almost 30 companies. Yeah, it's a big thank you to all contributors and also the Velox community. So here's our key goals in 2026. So in 2025, we actually implement several important features, including the performance improvement on Shuffle on BHA, and also the Spark 4.0 support, and data lake, and also GPU support. Those are actually already done in 2025. So in 2026, we are continuing the efforts. In general, we are introducing better support for the semi-structured data, including CSV, JSON, text, and we will continue to do the performance optimizations. And then, which I will introduce in later slides. And then we were expanding the platform support, including so x86 and ARM are already supported. We are adding the GPU support and also expanding the support to IBM Power and IBM System Z. And we are enhancing those nightly releases by enhancing those CI/CD pipelines. And we are adding the tuning recipes. In general, we are introducing some tuning method for including I/O, including memory, and some basic performance tunings. And more than that, we are adding the Spark 0-day support. So we are trying to add the Spark main branch support in our Gluten repo. Basically, we have a nightly job that pulls the main branch code of Spark, and then we were integrating into Gluten. And then we were, of course, another big goal for us is to grow the community. So this is Velox integrations we have done. It is quite very detailed here. So Velox primarily is is designed for the Presto project, and for Spark, there are some gaps we found, including the operators. For example, there's some different implementation on the expand node support. And then we also found some join types mismatching with Presto. We added all of those operators support, and then we found the in the Parquet or org support level, we also found some important gaps. For example, the timestamp support is kind of different in Presto and in Spark. So we implement all of those gaps, and also the function. So in general, Spark has like more than 300 functions, and almost all of those functions has different semantics in Spark and in Presto. It is very, very difficult for us to like close all of those semantic gaps. So it is actually a long tail task, and thanks to the Gluten community, like we just list all of those functions in the community, and then there are many contributors start to pick up all those tasks, and then gradually we contribute to the Velox side. Until now, we roughly completed the 260 functions, which already covers the majority usage in production environment. That's a very, very big achievement for us. And also on the performance and stability side, we are continuing our efforts on that. So it is still due to the different implementations between Spark and Presto. So naturally, we need to do more things than for the Spark design here. So yeah, this is very very informative slides. So here's a challenge we run into basically almost in almost every functions, every operators. So we did those, but till now we still have some results mismatching issues. We're calling for help on those issues. For all of those issues, we have already feedback to the community, Velox community, and we are now co-work with the Velox community to close all of those issues. All right, and for next, I will introduce several key features we have implemented in the 2025 and 2026. So the first one is, we have a new design on the GPU support. So we do have the full offload GPU support already, which thanks to the Velox community and the NVIDIA friends. But in Gluten, we are trying to do something a little different. So we are trying to introduce a concept called adaptive hybrid execution. For example, we are only offloading those compute-intensive stages into GPU, but for those I/O-intensive stages, like loading the table from S3 or GCS, then we just leave CPU on it. So in this way, we can like utilize the GPU more efficiently and reduce the cost from the big picture level. So we have a POC ready now, and the POC results is very promising. It should like roughly 2.5x performance improvements, while we achieved 60% cost reductions. The second one is from the hardware support. So again, thanks to the Velox community, so there's already some platforms is already working. For example, the x86 and ARM are already working, and GPU is in progress. But there are also some other platforms we are working on. For example, the FPGA and Power and the System Z. So IBM is contributing on the Power and System Z support, and I do know some engineers from China. They are working on the local ARM CPU support. So this is a great complement for the community. We could actually attract more developers and more interest on Gluten project. Yeah, the third feature for us is we are adding the 0-day support for Spark release. So initially we only support Spark 3.x, release only. And in the beginning of 2026, we are adding Spark 4 for support. Right now, we do support 4.0 and 4.1, but that's still like behind the Spark community. And in this year, the Spark community actually is trying to introduce a very aggressive releasing method. They're doing releasing every quarter. So to work with this, we are adding the Spark main branch support. So we are pulling their code from the main branch and then do the build at nightly. So in this case, if there's a new release from Spark, we could actually align with them and cut the branch in Gluten. Then naturally we will have the corresponding release for the related Spark release. Yeah, the fourth feature is we are adding more backend support. So initially, we are focusing on the Spark SQL mostly, and currently we do see some efforts from the community that tries to expand the support to different engines. For example, the Flink and Kafka engines are already there, although it is still in the very initial stage. But it's good to see Gluten like start to move into different workloads. Yeah, the next one is for the Gluten UDF code gem. So when we try to do POC or enable in custom environments, we found that the key performance limitation for Gluten is actually on the Java UDF. So usually in the user environment, they have some legacy UDFs either from Hive or from Scala, from Java UDF. We introduced the partial project feature, which actually can extract the UDFs, and then you can actually do project those supported expressions with native functions and only do the fallback for that specific UDF. But that can help, but that does not fix the issue entirely. So we are now leveraging ARMs to convert the UDF into C++ code, and then build that into a dynamic library, and then load into Velox. Yeah, I think our friends at Meta also have a session on that. They may have more experience to share there. So, but based on our early results, we are seeing very productive. This is very productive for us now. Yeah, last feature is we are doing the broadcast hash join optimization in Gluten. So initially we are reusing the shuffled hash join code path in Velox, which actually will build the table for each thread, which is a big waste on the CPU as well as the memory. So in the latest release of Gluten, we are adding those optimizations on the broadcast hash join. So instead of building the broadcast hash table for each thread, we will build that table for only once inside the executor, and then the executor will share that build map, hash map, and then reuse it, so that the memory footprint is reduced. Yep. So the next one is native lakehouse support in Gluten. So Gluten has inherited from the Spark design of data lake. So in Spark, they do have a very unified design for different data lakes like Iceberg, Delta, and Hoodie. And Gluten actually can inherit from that, and we do have a chance to unify design for all of those data lakes, because we only need to implement the APIs that Spark provides. So in this picture, we showed that the approach we are using. So we kind of reuse all of those control plane. So the metadata plane is not changed at all. Instead, we are just hooking on the data plane. For example, for the write code path, we are just do a hook, then offload the write to Velox write. Then we can support those data lakes very, very easily. Until now, we have iceberg and data supported already, and now we are working on the Hoodie and Pymon support. In our early results, we do see like up to 4x performance gain on the write intensive workloads. Okay, so for next, I will introduce a bit on the IBM Spark. So IBM Watson Data is part of IBM Cloud. On the left, it describes the technical foundations of the components. It does provide many features already, so including Presto, Spark, Mivos, and data stacks. It also supports all of those open source data formats like Parquet, Org, and yeah, many of them are supported already. So Spark in IBM software portfolio. So IBM actually was one of the first companies that offer Spark as a service. That was back in 2014. And then in 2015, IBM established the Spark Technology Center, which I guess most of you guys should have heard of this before. And now IBM is expanding. We are moving the expanding to the native engine support in Spark, which is a Gluten team. Okay, so here's a performance improvement we are doing mostly this year. So the diagram is basically describing a stack that the upper layer is from the client. We do have SQL clients. We do have data frame clients. And then in the middle, there's first we will need to optimize for the Spark optimizer. And then in the middle, we have Gluten Velox. And then when it goes to the I/O, we do have the local caching feature. And then we do have the support for Data Lake and Iceberg. And underneath, it is using the object storage like S3 or GCS ABFS. So to improve the performance of the workload, we actually need to inspect each layer of this stack. And yeah, one of the interesting things, if you, for example, we need to fix the S3 reading performance first. And then after fixing that, you may notice there's a new bottleneck coming up on the different layers. Yeah, and then here's a picture for our performance improvement in the past several months. So back to November 2025. So roughly we benchmarked the TBCDS 10 terabytes performance with all of those default parameters, and since then we start to optimize those with the methodology I just described. We did many optimizations, like roughly 10, 15 optimizations there. And in the past quarter, we are doing very good progress. As you can see in the picture, so we almost achieved 2.3x performance improvement in the past quarter. This is a very big achievement for us. And actually, we are actively upstreaming those optimizations, but some of the optimizations are not upstreaming yet. So yeah, feel free to approach us for more details. And then here's another picture for the benefits we observed from the custom workload. In this picture, so in the left, it's the default Java Spark performance. And then we introduced several optimizations, including offload the scan only option. And then we did many improvements on the table scan side, including the row group skip and split prefetching. And with all of those optimizations applied, we have seen almost 7x performance. And the customers are really happy about this. And then the last one is for the GPU work we are working on. So instead of offloading all of those operators into GPU, we found that in Spark workload, it is typically introducing very big data set. The data set is too big so that it cannot fit into the GPU memory entirely. So we kind of introduce a different mechanism to it. We are trying to introduce a new concept called adaptive hybrid execution. So basically, we leave those IO-intensive stages into CPU, and then we offload those compute-intensive stages onto GPU. And in 2025, we did a quick POC with single node based. That is a collaboration work with NVIDIA team. So we found that, like in the left picture, so for the first stage, we are still using the CPU as the execution. So we found the performance is almost similar with the original CPU-based execution. And then we offload the second stage, which is a very compute-extensive stage. It's a second stage from Q95. And it involves the very heavy hash aggregation, hash join. And then we found if we offload that stage to GPU, and then we can achieve very good results there. So with this POC in 2025, so we are very confident. We have more confidence on this approach. So in 2026, we are now expanding this to multiple nodes. So in this year, we are adding more features to allow the POC to run on multiple nodes. Basically, it actually reveals the resource profiling feature and at AQE, adaptive query execution feature in Spark. So we introduced a second resource profile, which is the GPU-based profile, and then in the AQE framework, we kind of inject our cost-based optimization there. We found if we found it is a very compute-intensive stage, then we will offload that stage into the GPU executor. So the patches are still under review in the Gluten community, but we do see very good results in our POC. So we made some POC with 3-node based environment, basically 2 CPU nodes plus 1 GPU nodes. And then we see roughly 2.4x performance improvement. And of course, with up to 67% cost reduction. Yeah, this is a very good achievement for us. Okay, so the last page is on the Gluten velocity, adoption velocity here. So we are actually collecting the production stories in Gluten community. Here's a picture for the adoptions. I actually removed some of the adoptions earlier than 2024. So starting from 2024, you can see the icon may be a little small here. So we have some early adoptions in 2024. In 2025, we have five more landing stories there. In 2026, we have roughly 6, 7 now. So it is still in the beginning of the 2026. So I expect there will be more landings in 2026. So this is a very inspiring story for us. And, I have also listed the Power BI page in the Gluten community here. Okay, so yeah, just to do a quick summary. So Gluten provides very strong Spark coverage and performance, and the community is growing rapidly In March 2026, we achieved the top-level project status. And IBM is improving Gluten with various components and the performance side. We worked closely with the Velox community to add the support for the Spark usage, almost covering every component in Velox. And yeah, Gluten Velox already showed very good performance in real production environments. In 2026, we will continue the efforts and then improving on those areas. Yeah, I think that's all the contents here. So some of the tech leads and team members of Gluten is here. So if you have any questions, feel free to reach out to us, and then we're happy to answer those questions. Thank you.